Welcome to another interesting question. It is based on function of function. It is a difficult question since it involves application of given functions in many different ways. We really want to find the solution of question 6, which is f of 2, 2. However, to get there, we have to follow a path, and I'll take you through this journey in this particular video.
Our approach, engaging minds, helps students think creatively and solve problems strategically. It helps them to connect with the context, visualize strategies, apply learnings, and bridge the gaps. Join Anil Kumar classes, gain confidence, and get ready for future. We develop mathematical and social skills for excellent performance of our students. The gift of education. I can be part of your success story, build strong foundation, ensure bright future. Join Anil Kumar classes, send an email on the address given here.
Let us now understand how do we solve such a question. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up a very important question which is based on function of function. I consider this to be a challenge question since it involves interaction of functions with functions in a very intricate manner, which will help you understand the concept very well. In case you want to learn from me, you can always send an email on the address given. The question before us is, let f be a function that associates two numbers x and y such that f of 0y is y plus 1, f of x0 is f of x minus 1, 1, and f of x plus 1, y plus 1 is f of x plus 1, y. That is how we have defined our functions. They are all related. You need to evaluate each of the following. So the real question is that we really want to find the value of f22. So basically we want to find the value of f22. So if you begin with that, you will realize that the previous values are all required. You get the idea. So we'll follow a simpler method, that is, we'll actually figure out the other values first. For example, we'll begin with question 1 to find what is f02, which you can directly use one of these relations and get the answer. I'd like you to pause the video at this stage and find the value for f22, right? So that is what you need to find. Now let us see how do we solve such a question. So let's begin by finding what f02 is. So f02, we could actually use the relation which is given to us right here. f0y is y plus 1. So this is equal to y plus 1, y being 2. So it is 2 plus 1. And so we can write this as 3. So that is clear, right? Similarly, if I want to find what is f10, in that case, f of 10, let me use a different ink for this side, and let me say green. So we have f of 10. We're trying to figure out this now. So that means the y value is 0. I can use the relation fx0. So that gives you f of x minus 1, which is 1 less than 1, right, is, let me write 1 minus 1 here, and y of 1, correct? So that really means f of 0, 1. So once you know that this can be written as f of 0, 1, then you use the first relation, right? In a way, we're using these relations in terms. So f of 0, 1, you know, is y plus 1. So that should be equal to 1 plus 1, and we get the value 2. So I hope this concept is clear to you. So that is how you can directly use the first two formulae or relations to find. So I hope these steps are clear to you, correct? So I'd like you to now pause the video and figure out how do we use these relations to find f2 of 0. Okay, so that is a practice for you. So f of 2, 0 is what? Since we know we have to use fx0, which is x minus 1, 1, you can write this as 1 less than 2 is 1, right? And then the value for y will become 1. So it is 1, 1. You get the idea, right? Now, since we have now f of 2, 0 as equal to f of 1, 1, what will you do next? Now, if these numbers, none of them have a 0, then we have to get to the third set of relations. So let me mark this now. Then we have to get into this set of relation, correct? Now, in this set of relation, we could write 1, 1 as f of, now 1 could be written as 0 plus 1, right? So we could write this as 0 plus 1 and 0 plus 1, thereby using the third relation which is given to us. And this is equal to what? This is equal to f of 0, right? So we have reduced from 1, 1 to 0, and then the y value remains the same as it was, right? So f of x plus 1 means whatever it was earlier, which is 1 in this case, but the y value reduces to 0. Do you get the idea? So that is how this relation works. And so stepping down a level, we are now in a position to utilize one of the previous two formulae to get our result, right? So now we know f of 0 is there, but what is f of 1, 0? Now f of 1, 0 was calculated as 2, right? Since f of 1, 0 was calculated as 2, we'll write 2 here. You get the idea. So that is how they are related. And now when we have 0, 2, we can now relate it with the very first relation, which is y plus 1, and therefore this answer will be 2 plus 1, which is 3. Does it make sense to you? So we found that f of 2, 0 is 3. So that is how these three formulae work. Now the question for you is to find the value of f22. So these steps are absolutely clear, I suppose, right? So let's go through them once again. So here is how we will do them. So the very first one was clear to us. We want to find the value of, okay, so first one was what? F of 0, 2 and f of 1, 0. Correct. So f of 0, 2 directly we read from the very first equation. And in this equation, we know it is y plus 1. So it is 2 plus 1, which is equal to 3. And as far as f of 1, 0 is concerned, we use the second relation. And so we could write this as f of 1 less than, I could write this as 0, right? 1 less than this value, and the y value being 1. And now we will use the first relation, and so we get the answer as 1 plus 1 equals to 2. So that is how we actually found these values, correct? So in the first case, we use the direct formula, which is f of 0y equals to y plus 1. And in the second case, we use formula number 2 first, right, which is x0 equals to f of x minus 1, 1. And then we use the first formula, correct? That was the combination. And the third question was to find f of 2, 0. So for f of 2, 0, we can use the second formula. So let's call this as a formula 1, formula 2, and formula 3. So we use the second formula. So where the x value reduces by 1 and the y value becomes 1. Now we have 1, 1. So none of them has 0. So we have to use the third formula. In the third formula, it is equal to f is reduced by 1. So 1 less than 1 is 0. And then we have a value of function where x is same and y is now reduced by 1. So 1, 0. You get the idea. F of 1, 0 we already found. So we can now write this as 0, 2. And since we know one of the zeros have come, we could use formula number 1 and get the value 2 plus 1, which is equals to 3. Is that clear to you? So I'm doing it again and again so that you understand how do we apply these formulas and get our result. Now let's do question 4, which was 4 was f of 1, 3. So let's figure out what is f of 1, 3 equals to. I would like you to now pause the video, answer this question, and then check with my solution. So as soon as I have f of 1, 3, I know I have to apply the third formula because there is no 0 in x or y position. So that formula tells me that the x value can be reduced by 1, and so we get 0 here, and the y value will be another function which relates with the original x value 1 and y value this time reduced by 1. You get the idea. Since we are f of 0 and something else, we could use formula number 1 and write the value as y plus 1. Now y plus 1 here is what? Y plus 1 will be f of 1, 2 and then plus 1. So basically, we need to find what is f of 1, 2. To get the value of f of 1, 2, we have to again use formula number 3. Correct? So, to get this value, formula number 1, 3 gives me f of x, which is 1 less, which is 0, and f of 1, 1 less for y value. And we have plus 1 here, correct? Therefore, this can now be written as, once you have one of the 0, 0 is for the x, then the value is y plus 1. And therefore, f of 1 plus 1, and then we already had plus 1, will be the result. Now, f of 1, 1, we already found as 3, right? So we know f of 1, 1 is 3. So we can replace this by 3. And we already have plus 1, which is 2, and we get the value as 5. Does it make sense to you? So we found that f of 1, 3 is 5. And that is how we utilize these formulae. Correct? So I hope these steps are absolutely clear. And now you can utilize this information to further find the solution for 5 and 6. In question 5, what do we want? We want f of 2, 1. So now you can calculate the value of f of 2, 1. And in question 6, we want f of 2, 2, which is our objective. So I hope these steps are absolutely clear. We already have calculated f of 0, 2 as 3, f of 1, 0 as 2, f of 2, 0 as also equal to f of 1, 1, which is 3. And just now we calculated f of 1, 3 as equal to 5. Now, since there is no 0 in this, it is 2, 1, we are going to use the third formula, where the x value reduces by 1 and the other value is a function of 2, 0. Now, what is f of 2, 0? F of 2, 0 was calculated as 3. So that was the whole idea, right? So when you work on these, you have to get back to original values which we calculated, and we're going to substitute them now. So basically, we get f of 1 and f of 2, 0 is 3, so we'll write 3. So now we have to calculate f of 1, 3. Again apply the third formula, which gives us f of 1 less than 1 is 0, and then f of 1 and 1 less than 3 is 2. So that gives you 0 in the x place. So we can apply the first formula, where the result is y plus 1. Y value is f of 1, 2. So f of 1, 2 is the y value. We'll add 1 to this, and that is how we are going to evaluate. F of 1, 2 is still not known to us. How do we calculate that value? We'll again apply the third formula. You see, iterative path of applying the same formula over and over again. That is very interesting. So for f of 1, 2, we can write f of 0 and f of 1, 1. Plus, we already have 1 here. Now you get a 0, so we can have y plus 1 as the result. So this can be written as f of 1, 1, which is the y value, plus 1, and we already have plus 1 there. F of 1, 1 was calculated as 3, and therefore that will be replaced by 3, and we will write 3 here for f of 1, 1 plus 1 plus 1 to get the result as 5. That is how we got f of 2, 1. Clear? So I hope the process is absolutely clear to you. I would like you to now do yourself and find the value of f of 2, 2. Follow exactly similar steps using these 3 given formulae and get your result. So I hope you find this useful and interesting. In case there is any difficulty, you can always check with me by sending an email on the address given. You can also learn from me. I hope you enjoyed understanding this question and the journey of how do we work with functions and function of functions. With this, we come to an end of this video. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.